And we're back for the second talk. Next up, we have Kevin Berendsen, who's a senior software developer at OpenValue. You've spoken at our meetup actually before. It was on a totally different subject, GSR 381, I think.
That's correct.
About, basically developing artificial intelligence capabilities in Java. That's not what you're going to talk about this evening. Going to talk about a really interesting product, I think. Tekton CI/CD. So I'm really curious what you have to say, and take it away, please.
Yes, thank you. Welcome back, everybody. Thanks for the introduction, Roy. Today I'm going to talk about Tekton CI/CD, what it is, and why we chose to use it in a project. So for one of the clients, I joined in a completely new team with one other guy. And a month later, we were supposed to get 3 more developers in the team. So we had a month to create a foundation to start developing service and applications. So like I said, we had no legacy, we had no older products that we had to maintain, and we're pretty much got time for ourselves to look into the new stuff. We had a couple of constraints from the solution architect that we had to run on OpenShift, pretty much all the services, and stick to the company's tech stack as much as possible. But if we could convince the solution architect otherwise, then we were good to go as well. So the same goes for our CI/CD solution. Most of the teams, all the teams were using Jenkins, and they were all provisioning them on Kubernetes, on OpenShift, and there was a bit of a hassle with upgrading, stuff like that, so the maintenance was a major pain in the ass. So one of the architects hinted us, maybe Tekton CI/CD is a very nice solution, because OpenShift integrates Tekton CI/CD as OpenShift pipelines really easily, so it was already installed on the cluster and we were just able to use it. So what Tekton is really all about, so it's a CI/CD solution on top of Kubernetes and pretty much running all the tasks in containers. So it leverages your Kubernetes cluster or your OpenShift cluster. All the pipelines are defined in YAML. So when you're used to creating resources in Kubernetes, you're pretty familiar with creating resources for Tekton. As a developer, there was almost no maintenance. So looking at a comparison between Tekton and Jenkins, like I said, we had almost no maintenance because Tekton was already there, and the cluster administrators, they were pretty much maintaining it. So if there was a new version of OpenShift, they were also installing a new version of Tekton. So there was no issue there. Same type of definition as Kubernetes resources. So if you're familiar with curating Kubernetes resources, then you're pretty much up to speed real fast with creating your pipelines in Tekton. And the reuse of Kubernetes resources is also a very strong pro for using Tekton, because if you create a secret, for example, or a configuration map, then you can really easily integrate that in your pipeline. And I also going to show that later. And also in the demonstration that I created, did the very same thing. As far as Jenkins goes, pretty much every developer once encountered using Jenkins, and all developers at that company in the business unit were familiar with the setups, knew how to use Jenkins. So they was very familiar with those guys. And there was much more knowledge on how to build pipelines in Jenkins in the business unit. And there was almost no experience using Tekton. So that was a really downside for using Tekton. So if we were stuck, we were pretty much left to the open source community for help. Luckily, we were able to figure out almost anything with the documentation that Tekton created, so there was a really big plus at the end. And yeah, what we could do is just copy paste another team setup, and hopefully it will run well. So copying the deployments and stuff like that. Yeah, coming back to Kubernetes, if you're not really familiar with Kubernetes, this is an example definition. At the top in orange, yeah, you pretty much see the API that you're using. In green is the kind of resource that you're trying to create. In cyan, you see some sort of metadata, which is very important. For example, the name. And then in the white, you pretty much specify the resource. So the attributes that belong to the resource you're trying to create. And in this example, is a deployment. And so that's going to be really similar to what we're going to do with Tekton. So what you really want to do is in your CI/CD solution, you want to execute tasks. And a task can contain multiple steps. And because we are leveraging Kubernetes, every task that you define runs into a separate pod, and every step that is defined runs in a separate container inside that pod. And you can pretty much use any image, Docker image that you would like for those steps. And there are many tasks that are already open for you to download and install on your Kubernetes namespace. So in this example, we've got a Maven task that has two steps. One, to properly set the Maven settings so that your Maven setting is set up correctly for your Maven goals to be executed. So a Maven goal could be running clean, and then a package to create a jar for your Java application. So what the task looks like is pretty much like this. So this is tasks are not really something that you create often, but you could be, because there are already many tasks that you can already download from the open source community. But just give you an example on what it looks like. So at the top, again, we define the API and the resource that we are trying to create. The metadata, which is really important because we define the name here. And then eventually the specification. Well, the specification contains a description, which is optional, but it could be very useful for someone else to use it if it's very complicating. The workspaces, I will elaborate a bit more on that. A workspace could be something that you share input and output with other tasks and pipelines. And there are different types of workspaces that you can define. For example, persistent volumes, which is something that's used often, for example, to check out source code from GitHub. And then in the next task, you run your Maven task to compile it or create a jar for it. You can include secrets, configuration maps, or pretty much any other type of storage that you have available in Kubernetes. So when we look at the workspaces in the task definition, we don't specify yet what kind of workspace it is. We just define, okay, we need a workspace. For example, we need a workspace for source. And we also want to have a workspace for Maven settings. So we create multiple workspaces. Again, we can create a description, but again, it's optional. Next will be the parameters, which is also optional. You don't have to define parameters. But in this example, we have a parameter called goals. And a context directory where the project is in. Again, descriptions. The type of parameter, you can have different types. For goals, you can have, like I said, you can have multiple goals that you want to include. during execution. By default, you can also create define a default value. In this case, it's just package. So if there is no default, it's mandatory to fill in the parameter on runtime, and if there's none, then if there's a default, then you don't have to define it on runtime. But yeah. And then next, the steps. Like I already said, we have Maven settings to set up your the Maven settings correctly in your in a certain workspace. And we have got Maven goals where we execute the Maven goals that you specified. In tasks, it's very important to configure these steps or define these steps in the order that you want to execute them. It's not possible to run them in parallel. For pipelines, it's something different, but I will get to that later. Then again, you can have images. You can set up an image. In this case, we have different images for those different steps, which will also create separate containers for it. And then again, the execution of the actual step. I won't go into much detail of these, but if you look closely already, you can see that we are using the parameters and the workspaces that's defined in the task to create the flexibility to execute different goals on runtime if you define the runtime task multiple times. Well, executing just one task is not really a pipeline, and like I already mentioned, you can have, for example, a task to check out code and a task to build your code and maybe even deploy your code or whatever. And we actually want to do that as well. So in Jenkins, we always do that, or any other CI/CD solution. And Tekton is not really any different. So a pipeline is used to combine tasks together, and a pipeline is pretty much a collection of tasks. And in the pipeline, we are referring to an existing task. So we don't define the actual task, but we're referring to a task. Well, hey, we want to, for example, start using Maven. And a pipeline could look like this. So at first, we want to check out the code. Then we want to run, for example, Maven build or compile. Then maybe do some quality checks, deploy the code, and then notify maybe on Slack, well, hey, the build failed or the build succeeded. And if you look at this, for example, if the deployment fails, you won't get notified in this scenario. So they come up with something like a finally block, where if anything happens during the pipeline, whatever is defined and finally, it gets executed as well. And also got the demonstration of that, where we have multiple notifications depending on whatever goes right and whatever goes wrong in the pipeline. And what good is that if a pipeline is only able to execute tasks in sequential order, you can also run tasks in parallel. By default, Tekton actually runs everything in parallel unless you specify otherwise. So in this example, we could perhaps create a Docker image while we are doing the quality checks. I mean, why not? It really, for example, if the creation of the Docker image only lasts 4 seconds and a sonar needs 5 seconds, then you won't notice the difference when we are creating the Docker image. So the duration of the pipeline execution stays the same. So coming to the pipeline specification, it's very similar again to the task specification, but the slight difference is here. Again, we specify the API, the kind. In this case, it's a pipeline. And we call the pipeline Hello World Service because we are building Hello World Service. And we want to deploy this pipeline in OpenValue Ops. This is a different namespace. And we have also a namespace for applications that we're gonna deploy to. So we are gonna show you that in a bit as well. Coming to this actual specification, we can define parameters similarly to whatever you have, whatever you do for tasks. So in this case, I define a branch that I want to check out. I want to check out with Git. Then I have a section where I can define the task. Here what you can already see is that I'm using a task reference to a kind task and git clone, which is the sole purpose of only checking out the repository. And then, well, you can have multiple tasks, but I will show you that. I will show you that later in an example. But yeah. And then we've got workspaces again. You don't define yet what kind of workspace it is. You just define there's a workspace that you would like to use. Usually in the pipeline, you define a workspace and then you just pass it along to a task. So that's really the same goes for parameters really in a pipeline. So just passing along, just similar as you would have with a Java class where you only pass the parameters that you receive from a class or from an input to another from another class. So what does a task reference in a pipeline look like? Because the screen was was too small for it to show it on in the previous example, but here we have Maven build. We call it Maven build, where we just where we refer to the task Maven, and we're gonna run it after the fetch repo task. So this is the part run after where you define, well, we wanted to run it in sequence rather than parallel. Then we set the parameters. For example, in this case, we skip the test. At least we set the parameter to skip a test. We clean it and then we package it. And then, as you see for the workspaces, in the previous example here, we have workspace, shared workspace, and Maven settings. And here we just pass them along to the tasks. So for our pipeline, that we're gonna create. So it's slightly bigger than I show on the slides. But here we define multiple parameters, one for the git commit hash, one for the branch that we use later. Then we have the fetch repo task where we check out a certain repository and where we check out by branch. We set the workspaces, so that's not really that difficult. We built a project with Maven, which is a very simple Java application, by the way. We use Spring Boot and we Dockerize it later, where we say create image after building. We're skipping the whole Sona stuff because that's gonna take too long. We're just gonna create an image, and where we use a Docker file that's simply basic. We're just using an OpenJDK version from Azure, and then it uploads it to a certain repository. So this is a Docker registry. Sorry. So we are uploading it to a Docker registry, and then later on we deploy it using Helm. Helm is just a tool for which has some templating where we make deployments of Kubernetes resources really easily. As you can see in the parameters, we deploy it as Hello World service in a different namespace than where the pipeline lives. And then finally, we notify if the build failed. So we get a Slack message if the build failed on a certain branch with a certain commit. We get a notification if the deployment fails. And then if it succeeds, then we get a successful message that is deployed successfully. And at the end, we are defining the workspaces. Like I already mentioned, that the workspaces can be different. For example, when creating the image, we also want to upload it. And this, so we need to provide some sort of credentials for Google Cloud Platform because I'm hosting the Kubernetes cluster on Google Cloud Platform. We also need to pass along the credentials. So if you look at the runtime, at the pipeline run, where it actually, which is a resource that you create to run a pipeline. It's really small, but where you can see, okay, we're gonna create a pipeline run resource in the same namespace, and then there's something different here. For other resources, you usually specify name, but because this is a resource that we create frequently, we just want to generate a name, because otherwise, every time we want to create this resource, we have to define our names ourselves, and well, that's maybe not something that you won't want to do or create a hash yourself. The platform already handles that for you. When looking at the specification, we're referring to a pipeline similar as you would when you're referring to a task. We set the parameters. So this is the moment where we set the parameters correctly. Well, this is the git commit hash, the branch name that we're setting. And this is the, like I mentioned, where you can specify the different types of workspaces. So for Maven settings, well, we're not downloading dependencies from a special artifactory where we have to pass along the credentials to, or something else. So we can just define, well, the Maven settings is just an empty directory and you don't do anything with it. But you have to specify it because otherwise it breaks. There's no default workspace, so that's one of the downsides. The shared workspace is pretty much where we check out the code, build the code. So this is something that we want to be able to allow tasks to write to. So we create some sort of persistent volume to be able to do that. So we are leveraging the Kubernetes platform to write storage to. And then in the end, we say, all right, the Google Cloud Platform credentials, we want to read that from a secret. So we're using an existing secret that I uploaded to the namespace to use that in the pipeline. The majority of the workspace types are read-only, except for persistent volumes and some other types. But the persistent volumes is pretty much a type that you would use frequently. So then we have defined a pipeline. We don't want to trigger the pipeline manually every time by hand or running a CLI script. We want to do it automatically. That's what you would usually do. So for example, if you commit to a certain branch, that it will trigger a pipeline for you. So Tekton created something like an event listener. So an event listener listens to events and allows you to trigger based on certain criteria. So a trigger could have an interceptor where it checks, are you committing to the main branch, then trigger the pipeline, or use these parameters for the pipeline that you want to trigger. So in our scenario, we had multiple triggers for different branches. For example, if you develop on any feature branch, if you commit on any feature branch, it will it will trigger a new pipeline and deploy that version onto a development environment. If you for example, if you merge that feature branch into the develop branch, it will commit to staging. And then for main, it will push to production. That's how we set it up. It's pretty similar to what the other team setup in Jenkins, we want to have that pretty much the same. So the transition for other teams, if we want to go to Tekton, the flow doesn't change really that much. So we try to copy that basically. So when looking at the event listener, again, we're starting with the API that we want to use. We're creating an event listener. We name it. And then that comes to a part where we define multiple triggers. We name the trigger main branch, for example. Then you have interceptors. I don't go really specifically, I don't really dive deep into the interceptors because they can be quite complicating sometimes. But that's where you configure it, and there are many examples on how to configure your interceptors. Then you have bindings, and bindings are pretty much parameters that you pass along to your pipeline run. So the bindings that you define here pretty much passed on to the template that you see below. And there are two types of bindings. You can create a resource for it, where you create a trigger binding. That's mostly useful for bindings that are the same for many other pipelines. Otherwise, I would just inline it, because the overview is you keep everything together in the single resource, in the event listener resource, and so there's less magic happening there. Same goes, for example, if you use many abstraction layers in Java. That can also be very complicated. For where does this value come from, or where does this method come from, or where does it override this method? Same goes for here. And the trigger binding looks pretty much very similar to just the bindings. You just configure the parameters. In this case, we have a parameter called hello and the value world. Not really rocket science there. And then we define the template. I always try to stick to creating a trigger template resource, because the trigger templates tend to be also really big. So it looks very similar to a pipeline run, but it adds more configuration to it. So that's why I try to usually refer to as existing. And I can show you. Oh,
these event listeners are assumed quite specific for the Git provider you use, right? GitHub, GitLab. Is it like implemented specifically for these platforms? Or?
The interceptors, they so the question was that about the interceptors, are they specific for different Git repository platforms? For example, GitHub has their own interceptor than any other Git platform, really. So that's true. But we're hosting code on GitHub, and for us it wasn't much of a problem. It was 3 lines of code, and we were good to go. We also had interceptors where we extract certain names from the branch name, so it tended to become a little bit bigger. But yeah, that's true. Looking at the trigger template, we defined the trigger template here. Specification, parameters. So these parameters, they need to correspond to the trigger bindings that you define in your event listener. So they need to be the same. And then you can define resource templates. Resource templates are pretty much resources that will be created when the trigger template is running. You can define multiple, but in our use case, we're only creating one, and we are creating a pipeline run for it. And what you can see here specifically is that we are passing along the trigger template parameters to the pipeline parameters. And so that's basically what we were doing. So again, it's really about passing along the parameters in the workspaces. So when you've got everything assembled, you've got an event listener with multiple triggers or one trigger, and it creates a pipeline run resource which refers to a pipeline. So for the demo, I'm gonna skip the event listener part. I used to have everything running in OpenShift, but that started crashing locally, so I started using Google Cloud Platform to create a Kubernetes resource, and didn't really get time to set this up. But we are going to trigger a pipeline run manually. We're going to check out, we're going to also check out the image that's created, and we're going to also test the application. And so we're going to test the deployment. So just to check, there are no pipelines yet. I'm using the Tekton CI. It gives you better formatting, better output than if you would use kubectl CLI. But you can use it as well. It's not really mandatory, but it's easier. So there are no pipelines yet. And what we want to do is we want to create the pipeline resource. So here we've got the pipeline resource that we want to create. So that I showing you earlier. And I'm just going to execute it. Takes a couple of seconds. And here it says that it has been created. So if we run the Tekton pipelines command again, it will show that the Hello World service pipeline has been created 8 seconds ago. Also want to check what the pipeline contains. So we describe it, Hello World service. And then here it shows you in the output pretty much the stuff that you defined in the pipeline. Here also you can see the different tasks that we defined in the different workspaces. And at the bottom you can also have an overview of the previous run pipeline runs. So that's what we're gonna do next. But first we're gonna see if there are any Docker images that are already created in the repository. So here I'm using Google Cloud Artifact Registry, where I host my Docker images. I list the images, and it shows no items, 0 items for any image at all. So also gonna check, are there any pods running on OpenValue production? There are no resources found in the OpenValue production namespace. So we're gonna create, so there's a difference there. So if you wanna create you have to create a pipeline run instead of applying a pipeline run if you use generate name in the metadata. So here we go, pipeline run. It has created the pipeline run. We're gonna check that out using the Tekton CLI pipeline run OpenValue ops list. Here we see that we've got one running. I'll also want to check it out, how it's doing, what's doing so far. So it already succeeded in fetching the repository. You can also see the workspaces that I bind to the defined workspaces the value that you use as parameters. So pretty nice tool to see how your pipeline is going, how it's doing. Gonna wait a couple of seconds more. Takes about a minute or two to complete.
I have a question. While
Yes?
you're waiting, can you also show the UI console?
Yeah, Kubernetes doesn't have one, but not by default. But Tekton does have a pod called dashboard, but you have to install it separately, where you can have basically the same functionality as you would have in OpenShift. But I can show you OpenShift the OpenShift pipelines later. Now, so here it has created the image already. So we're gonna check that out. If it's there in the registry, here we can see we just created one at this time. And I got a notification on Slack. It's pretty small, but it here says that he deployed the master branch successfully. So we got a Slack notification there. So we're gonna check out production. And we've got a single pod running there. Let's just port forward so we can test the application. I would have to create a second tab. Which port was I using? It shows Hello World, because I just created a Hello World application with a Hello World resource. So let's just say that we want to change the output. Just say hello OpenValue meetup. Gonna save it. Gonna close this one. Gotta commit it. Yeah, well, I need the hash. I'm gonna copy that, gonna change that in the pipeline run. There we go. Oh. I think that was it, right? Yes, that was it. And now if we gonna create another pipeline run, list it while it's running. In the meantime, I can look up OpenShift pipelines. Documentation doesn't really show it yet. Maybe UI. But there you can see it has a very nice overview of the pipelines and also the last run. So that's very similar to what you would have at the CLI, but it's a little different. Then you have an overview of pipeline runs. Yeah, it looks really nice. You can also start a pipeline run from this UI. You get a nice details overview of the task that is executing. Yeah, really basically everything that you would have in the CLI, but then in a UI. Should be almost done. Oh yeah, I will get a notification soon. The second notification just came in on my Slack channel. I'm gonna check it out if the new pod has been created. The age of 33 seconds, so I'm just gonna assume yes. Gonna port forward it again. And when I curl the statement, we get the new response from the application. So that was a really basic example that you can really easily create your pipeline in a single definition and trigger it very easily with really basic stuff, and then pretty much everything that you would also have in Jenkins, well, the majority of in this demo. So that was pretty much it. So first of all, thank you for watching.
Right, let's hear it from Kevin. Before we start the questions, Kevin, here's also to you. Thank you.
Thank you very much.
Enjoy it. So it's amazing how far we've come with software development from maybe in the 90s, copy and pasting code to Word documents to keep track of it, using source control, using continuous integration, CI/CD, and now with Kubernetes and these really fancy tooling. It's pretty awesome. It was a really nice overview, Kevin. Does anyone have a question at this moment to Kevin? Yes, please.
What is the time that it took to go from Jenkins to Tekton?
Well, we didn't.
Repeat for the.
Oh, sorry. Yeah. So the question is, what was the time needed to go from Jenkins to Tekton? Well, for us it was none, because we're a new team. We had no legacy. We didn't have Jenkins service yet. So for us it was pretty easy. But from another OpenValue colleague who's transitioning, I don't know how long it took for him, but yeah, it will take time. You usually have both solutions running at the same time in the beginning, but yeah, for them it's very convenient to start using Tekton rather than Jenkins. But yeah, the answer for your question, I don't know.
I think the most steps are the same, but it's a different structure you have to get used to that. Did that take a long time? Because most people are mainly used to Jenkins stuff.
So the question was that the structure for Jenkins is differently than to Tekton. Yeah. Well, I use various CI/CD solutions. I also use GitHub Actions. Recently used Azure DevOps pipelines. So wasn't really much of getting used to. The basic principles are pretty much the same. You just have to get used to the syntax. What I do know is that for the people that were using in Jenkins, you also have some sort of pipeline definitions in a single file or something similar. Look pretty much the same, except just a different syntax. And maybe just some fine tuning. For example, we used Canico as a solution to create images, but in Jenkins you use a different solution to create Docker images and upload that. So I think that was the biggest issue there for us to figure out. Yeah, that was pretty much it.
Any other questions at this moment? don't think so. So again, Kevin, thank you.
Yeah, thanks.